Please bow your heads and let us pray. Dear Jesus, please show me how to spend this day sharing your love in every way. Help me to be kind to everyone, to play and laugh and have lots of fun, shining your light and giving your grace, sharing your joy with a smile on my face. Angel of God, my guardian dear, to whom God's love commits me here. Ever this day be at my side, to light and guard, to rule and guide. Amen. Hinaya!
Alright, good afternoon, grade 8 learners. Are you ready to learn for our new lesson for today? Can I have a reaction, please? Alright, I can see here that everyone is ready. So, let us meet your teachers. I am Teacher Eunice, and then we have Teacher LJ, Teacher Charlie, Teacher Ann, and Teacher Eliza. So now, who's excited to learn something new? Next slide, please. Alright, so the first activity is that let's test what you know. So in this activity, next slide, please. So let's test what you know. In this activity, we have a few questions to recall and brainstorm your minds kung unsa inyong naibawan about sa volcanoes. So can I have Miss Brianna Tapdasan? Are you there?
Hello.
Yes.
What comes in my mind when I hear the word volcano is that it is dangerous when you live near the active volcano po.
Alright. It's dangerous daw when you hear the word volcano. No, mahunahunaan man jud nato na very dangerous jud ang volcano when it comes to our mind. Especially if we live near a volcano, right? So next slide, please. Do you think all volcanoes are dangerous? Can you name any active volcanoes here in the Philippines? Yes, Miss Nicole.
I think that not all volcanoes are dangerous. The only dangerous ones are the active volcanoes because they can erupt at any time. And active volcanoes that I know are Taal, Mayon, and Canlaon.
Alright. Alright, very good, Miss Nicole. Of course, the very famous volcanoes here in the Philippines are the Taal and Mayon volcano. Next slide, please. So what long-term effects can volcanic eruptions have on the environment and the community? Miss Vinci.
Well, volcanoes can you repeat the question again? I'm sorry, ma'am.
Alright, so the question is, what long-term effects can volcanic eruptions have on the environment and the community?
Long-term effects include the health effects. It can endanger them in their respiratory system. Aside from that, it can cool our atmosphere. Yes.
Yes, mo na siya ang mga long-term effects, no? Ang health, ang pollution, mo na siya. So, next slide, please. Alright, so awesome. So, let's give our classmates a round of virtual applause, please. Virtual applause, everyone. Alright, so for our next activity, we will have a puzzle clues, build and guess the volcano. So, for this activity, you need to guess the puzzled pictures. And then, Name the volcano and where it does belong. What country it does belong, alright? Next slide, please. You can raise your hands, guys, if you want to answer, or just type in the chat box. So, puzzle number 1. Raise your hands or unsa man inyohang nabawaan, please. If shy mo. Yes, Cole. What's your answer?
Taal volcano.
Alright, Taal volcano. What country does it belong?
In the Philippines.
Alright, correct. It's located in the Philippines. The Taal volcano is a cinder cone volcano located in the Philippines. Next slide, please. So what puzzle is this? What volcano is this? Anyone? I need to. Yes, Miss Jamela.
I believe that it's Mount Fuji, ma'am.
Is it Mount Fuji? Let's check if it's Mount Fuji. So it's Parikutin volcano in Mexico. It's a cinder cone volcano. So it is not Mount Fuji. Alright, very familiar puzzle. What volcano is this? Anyone? Yes, Cole.
Mayon volcano in the Philippines.
So it's Mayon volcano in the Philippines. Next slide, please. Kani, very familiar din siya. Mo ni siya ang gi-answer ni Miss Teo ganiha. Yes, Miss Teo.
Kana, ma'am, kay Mount Fuji na, ma'am. From
Alright,
Japan.
Yes, it's Mount Fuji in Japan. It is a composite volcano. Next slide, please. Kani, this is located in the Philippines, ra. Anyone? Miss Jean Gale.
Kanlaon.
Is it Mount Canlaon? Let's see. It's Mount Bulusan. It is a shield volcano. So next slide, please. Last, I think this is the last puzzle now. Anyone? Yes, Miss. Let me see here. Miss Ricazel.
Mount Everest.
Let's see if it's Mount Everest. Is Mount Everest a volcano? Alright, it's Mount Mauna Loa in Hawaii. It is a shield volcano. Alright, next slide, please. So now I am very honored and I will welcome you to our topic for today. So our topic for today is volcano. So are you ready to dive deeper of our topic? Alright. So before we dive in, let's read first the objectives. So learning objectives. By the end of the lesson, the grade 8 students with 75% proficiency must have first, identify from the pictures the different types of volcanoes found around the world. Next is to demonstrate the different types of volcanic eruption by a simulation activity. Then, compare from the simulation activity the type of eruption the volcano eject, and lastly, appreciate the importance of disaster preparedness for volcanic eruption by creating an emergency plan. I will present to you to the next teacher, Teacher Charlie Matero.
Okay, thank you, Miss Eunice. Now, good day, class. Today we're going to become young volcanologists in our eruption simulation. So, this activity will help us better understand how different volcanoes erupt and what their lava looks like, and how dangerous or calm they can be. So, you will be divided into three groups, each representing a specific type of volcano: cinder cone, shield volcano, and composite volcano. So each team will conduct an eruption using a 3D model and a chemical reaction. So you will observe how your volcano behaves and record your findings. So I already posted the grouping, so I will call only the leaders to lead their member. So here are your group assignments. So the group one will be Team Cindercone, leaded by Miss Cantos. Group two will be Team Composite, leaded by Sarah Ohm, Jean Gale. And group three is the Team Shield, leaded by Ventek Griven. So each group will have its own station with materials ready. You will have 15 minutes to perform your eruption simulation and complete your observation sheet. Now, let's watch the video simulation of Team Cinder Cone.
Iyak mo eh. Nakamute ka. Balik.
Sorry. Okay. Now that we've seen the video, let's hear from our team Cindercone. So please tell us about your volcano shape, eruption style, lava flow, and which real volcano it reminded you of. Okay, Miss Cantos.
Okay, so hi everyone. We are the team Cinder Cone, and here's what we observed in our eruption simulation. Our volcano was small with steep sides, which is typical for cinder cone volcanoes. When we added the baking soda to the vinegar, the eruption was explosive and happened quickly. The lava or the reaction liquid moved very fast, but it only spread in a narrow area around the crater. We rated our explosion as an explosion level as a 4, which means it was explosive but not the most extreme. A real volcano that is similar to ours would be Paricutin in Mexico because it is small but had a very powerful eruption. Thank you.
Okay, great job. Let's have a virtual applause for the team Cindercone. So I love how you connected the eruption style to the volcano shape. You gave very clear observations and a real life example, which shows you're thinking scientifically. So keep up that enthusiasm and attention to detail. Next, let's watch the video of Team 2 Composite Volcano. Okay, now let's hear from Team Composite Volcano. So where are the Team Composite Volcano?
Hello, am I audible?
Yes, you are. Please start.
Okay, good day, classmates. We are Team Composite Volcano, and here are our observations. Our volcano had a tall and steep shape, which matches the layered structure of a composite volcano. The eruption started a bit slow, but then became very explosive, showing us that composite volcanoes can have both effusive and explosive eruptions. The lava flow was moderate in speed, not too fast, and it spread out in a medium-wide area. We rated the explosion level as a 5, which is very explosive. It even splashed out a bit. This reminded us of real volcanoes like Mount St. Helens in the United States or Mount Fuji in Japan, which are both composite volcanoes known for powerful eruptions. That's all from Team Composite. Thank you.
Okay, let's give a round of applause for Miss Sarah Om. Excellent work, Team Composite. So your presentation showed a strong understanding of how complex and powerful composite volcanoes can be. So I especially liked how you noticed the mix of eruption style. No, well done for comparing your model to real examples so accurately. Now let's see the video of Shield Volcano.
Love?
Okay, now let's welcome the Team Shield Volcano for their presentation.
Hello! We're Team Shield Volcano, and we'd like to share what we observed. Our volcano had a wide and gently sloping shape, which is exactly what shield volcanoes look like in real life. When we poured the vinegar, the eruption was effusive, meaning it was calm and not explosive. The lava flow was slow, but it spread very wide across the tray, just like how lava from shield volcanoes can cover large areas. We gave our eruption an explosion level of 2, which means it was calm. This simulation reminded us of volcanoes like Mauna Loa in Hawaii, which have gentle eruptions and wide lava flows. Thank you for listening.
Okay, let's give a round of applause for the Team Shield. So your description was clear and thoughtful. So you really captured the gentle, flowing nature of shield volcanoes, and I am impressed by how well you connected your model to Mauna Loa. Great teamwork and explanation. So now that we've seen all the eruptions, let's take a moment to reflect. So I'll be asking 3 questions to be answered. So please raise your virtual hands if you want to answer. Okay, who wants to answer this one? This question. Okay, Miss Sarah Ohm, what did you learn about the relationship between a volcano shape and its eruption style?
I learned that the shape of a volcano gives clues about how it erupts. Cinder cone volcanoes are small but have very explosive eruption. Shield volcanoes naman can have wide bases and slow flowing lava, while composite volcanoes can have violent eruptions because they are tall and steep.
Okay, very good, Miss Sarah Ohm. Okay, next question. Who wants to answer? Okay, yes, Miss Cantos. How can understanding volcanic eruptions help communities prepare for real life disasters?
Okay, thank you for that question, ma'am. For me, understanding how a volcano erupts can help the communities create better evacuation plans. Like, for example, if a volcano usually erupts violently or suddenly, people living nearby uh, can be warned early and prepare emergency kits or have a clear evacuation routes.
Okay, great answer, Miss Cantos. Let's give a round of applause. Okay, next slide, please. Last question. Okay, yes, Miss Vintik. What part of the simulation surprised you the most and why?
Hello, Miss. Good afternoon. I was surprised at how fast the vinegar and the baking soda reacted to create an eruption. It made me realize how sudden and powerful real volcanic eruptions can be, even if the volcanoes looks calm on the outside.
Fantastic insight, Miss Bentik. Okay, so each of your answers today show that you're really thinking like real scientists. So don't ever underestimate your ability to learn through doing. So you all worked hard, supported your teams, and made excellent observations. So keep that excitement and curiosity alive. You never know, one of you might a future volcanologist. So okay, now let's hear from the teacher. Let's hear from teacher Vixir to discuss more about volcanoes.
Okay, so this time around, we are going to proceed with let's discuss volcanoes. So earlier, you were able to see different types of volcanoes, which also includes their structures, though on how viscous their explosion was. So let's dig deeper about our topic. So next slide, please. Let me ask you, how do you think the shape of a volcano affects the way it erupts? Like, does a steeper volcano have a stronger eruption compared to a wider one? Anyone who would like to share their opinion?
Yes, Miss Jean Gale, you are acknowledged.
O- Okay, so the shape of a volcano is closely related to how it erupts actually because the shape is formed by the type of lava and how it flows or explodes. Okay, ang steep volcanoes like composite volcanoes, no, they usually have thicker and stickier lava. Ang wide volcanoes, they're like the shield volcanoes, have thin and runny lava.
Okay, so thank you so much for sharing that one. So this time, let's go ahead and proceed then. Anyone who would like to volunteer, like, can you name a real life volcano in the Philippines or worldwide that looks like that looks like one of the models that we've shown you earlier? Yes, Miss Hannah.
For example, Mayon volcano in the Philippines looks like a composite volcano because it is a tall and perfectly shaped. And for the cinder cone, the example is Saal volcano because it's smaller and inside a lake. And for the shield volcano, for the example is Mauna Loa because it has wide and has gentle slopes.
That's right. Thank you so much for giving such a very good example. No, so let's right now then let's go ahead and let's know more about volcano. So the term volcano, this one refers to a mountain or a hill, typically conical, having a crater or vent in which lava, rocks, fragments, hot vapor, and gas or have erupted from the Earth's crust. The lava and other volcanic materials originated from molten materials. These are what we call magma, and they are found beneath the surface of the Earth. And magma and other volcanic materials are finding their way to the surface where they are expelled through openings like cracks and holes. Any activity that includes the movement of magma towards or into the surface, this is what we call volcanism. So this time, let's go ahead and check for the main features of volcanoes. So these are like the most common parts or what we usually tackle about, especially when we talk about volcano. First is we have the magma chamber, and we also have the second vent, the secondary cone, the volcanic bombs. We also have the ash cloud, the pyroclastic flow, a crater, the main vent, and also the lava flow. So let's tackle one by one about the definition in terms of some of the or the main features of a volcano. So a summit, this is the highest point or the apex of the volcano. We also have what we call the slope. These are the sides or flanks of a volcano that radiate from the main. And also we have what we call a base. This is the lower outer part of the volcano. And right now, let's tackle about the geological features of a volcano. So these are like the features that you've seen earlier from the picture, which is that also tackles about the main features. So the most common is also what we have a magma chamber. This is a region beneath the vent of a volcano where molten rocks or magma is deposited or stored before eruption. We also have the main vent. This is the main opening or outlet on the surface of a volcano that emits lava, gases, ash, or other volcanic materials. We also even have um, I don't know if I'm saying it correctly, but candid. It is an underground central tube-like or pipe-like structure of a volcano that connects the magma chamber to the crater through which the magma travels. Okay, next slide, please. Now let's go ahead and proceed with other features or geological features of a volcano, which is what we call the side bend. So the side bend, from the word itself, this is they found on the side. This is the smaller outlet through which magma escapes. So if we have the main vent, we also have like those little side vents. Number five is the crater. So it is a mouth, it is the mouth of the volcano, which is a funnel shape or bowl shaped hollow at the top of the vent from where magma, ash, and gases comes out. So from the videos that you've seen earlier, you can also notice how each volcanoes have different sizes of their crater. So it is also one of our indication on how we can be able to identify what type of volcano that we are dealing with, or on especially or it also tackles about what type of magma it comes out to. So this is one of the geological features that we can determine what a volcano is. Next one is what we call the lava. So the lava, it is a molten rock which is given off onto the surface of the earth when a volcano erupts. So these are the those molten rocks that you've seen. So from the experiment that the groups did earlier, the lava represents the baking soda and also the vinegar. So it really depends on what type of volcano you're dealing with and also how viscous the lava or the magma is. Now this time around then, let's go ahead and proceed with our other main features of the volcano, which is what we call the ash and gas cloud. So this is a mixture of rock, minerals, glass particles, and gases expelled or pushed out of the volcano during volcanic eruption. So aside from lava, we also have this ash and gas cloud. These are the other pollutants or not ingredients, but other part of the volcano when it erupts. So this time, from what you have learned earlier, let's give some reflections and okay, may I ask someone? Anyone from the class who would like to give their insights about what ways can a volcano shape affects the type of eruption it has? Anyone from the class who would like to give their insights? Okay, to call in, Miss Nicole, yes, you're acknowledged.
Um, Cone-shaped ones trap pressure, causing explosive eruptions. Wider ones release it slowly.
Okay, yeah, that's right. From what I've mentioned earlier, it also really depends on what type of openings release. It really explains on, on how it affects the volcano's eruption, especially with with the shape of the volcano. So yes, you're right. So next slide, please.
How do the slopes of
Okay.
volcano?
Now, anyone who would also like to share their insights about how do the slopes of a volcano affect the flow of lava during an eruption? Anyone who would like to give their insights or on what they learned
Giisa lang.
with the features earlier, and
Isa lang.
who would also like to give their also opinion about this one? Anyone from the
Dili, isa lang.
class?
Tabi na yun. Tabi na yun, Cole. Tabi na yun ba?
Steep slopes make lava flow faster and further gentle slopes slow it down.
Okay. Well, thank you so much for that. So yes, it also the slopes of a volcano also give significantly effect on how a lava flows. Also, with stepper slopes, which also give faster flow. We also have what we call a gentle slopes, which give a slower flow as compared to the stepper one. We also have what we call a flow direction, which is the slope also determines the direction of the lava it takes. And the lava type matters too, aside from that one, like even on a steep slopes or thick, sticky lava may not flow far, while thin, runny lava like a basalt flows easily, especially on a gentle or gently slope. So this time around, then let's hear teacher Eliza with next report.
So now that we have discussed what a volcano is, what its features, its main components, now let's talk about its type. First, we're going to talk about types of volcano based on their structure. So the first structure of a volcano is known as a cinder cone volcano. So this volcano is the simplest type of volcano. It's built from particles and blobs to solidify lava ejected from a single vent. So the type of eruption in the cinder cone volcano is actually explosive. So why? This is because the cinder cone volcano actually has a very simple system, no? So the volcanic chamber vent is actually connected to one path. This means that those pressure caused by water vapor and many more is actually increase the possibility of lava to erupt in a violent way. So this is why the cinder cone has an explosive eruption. So lava is thrown into the air, breaking into small fragments that solidify and then fall as cinders around the vent, forming a circle of a cone. So the the structure of the cinder cone is actually based on its eruption. The eruption is a violent one, so it throws lava that solidifies, and this then carve a circular and oval cone in its vent. That's why that is what it looks like. So the cinder cone volcano has steep slope
wide crater and its most abundant type of volcano. So, one important characteristic of cinder cone volcano is that it is steep, slow, and has wide crater, and it is one of the most prominent volcano in the world. So, the most famous example of cinder cone volcano is Taal volcano. So, the Taal volcano actually has different types of volcano structure in it, but it is considered cinder cone volcano because of its explosive eruption. So this Taal volcano is found in the Philippines, and another famous one is the Percotin volcano in Mexico. So the other type of volcano is the composite volcano or the stratovolcano. So these volcanoes are large, typically steep-sided symmetrical cones of large dimension formed by alternating layers of lava flows, volcanic ash, cinder blocks, and pyroclastic materials. So the composite volcano actually also has an explosive type of eruption. This means that the lava is ejected, forming pyroclastic materials into the air. And its lava is highly viscous. So when viscous lava hits the atmosphere, it actually cools down. This then makes the volcano steeper. This is why it is very steep because of the liquefying lava. No? One of the most important features of the composite volcano is that its conduit system from which magma rises to the surface of the earth. So features composite volcanoes is actually that magma is actually branching off. This makes composite volcano to have many secondary vents. This is the one key difference of the cinder cone volcano and the stratovolcano. So the stratovolcano is formed from viscous or sticky lava that does not flow easily. So as I said that the composite volcano or the stratovolcano has a very highly viscous lava. This means that they resist flow. So when you resist flow, the movement of lava is very slow. So when the movement is very slow, it tends to solidify it at its out, outside part of the volcano. So this builds up the volcano, making it steeper and steeper. So the most famous example of composite volcano or stratovolcano is the Mount Mayon and the Mount Fuji, very famous to us, no? Mount Mayon in the Philippines and Mount Fuji in Japan. So as you can see in the picture, these two volcanoes are actually considered one of the most perfect volcano in terms of its shape. No, as you can see, it is perfectly symmetrical, and it has very steep slope. No, this is why this is part of the wonders of the world. So next is the shield volcano. So the shield volcanoes are large, broad volcanoes that look similar to shield. So one key fun fact: the shield volcano is actually named after a shield of a hero. So it's named after the shield of a hero because it looks like shield of what heroes would carry. So this volcano is built almost entirely with lava because these volcanoes are steep. So unlike the composite and the cinder cone volcano, shield actually has an effusive eruption. This means that it doesn't eject violently, no? Instead, lava just flows sa iyang kilid. And the lava of the shield volcano is actually less viscous, meaning no, they just flow easily, no? And it flows faster than those of composite and cone volcano. This means that this means that this type of volcano isn't very steep because the lava actually flows down before it's solidified. That's why it isn't steep. Next, no, is the examples of these types of volcano. So, the first is the Mount Bulusan in the Philippines and Mount Mauna Loa in USA. So, this is the example. So, as you can see, it has the characteristics of what I've said before. You can see sa Mount Mauna Loa, it's very, uh, it's not that steep compared to the other two volcanoes. And when erupt, it doesn't have explosive, but it is effusive, meaning lava just flows with a bit of interaction with the atmosphere, but their their eruption isn't as violent and not as dangerous as the other two. So those are the examples of volcanoes based on their structure. So now let's ask. So let's digest what we have discussed. Let it sink in first. Let's take a moment to remember all the volcanoes, their characteristics, and but why they are that way. Now let's reflect. So I'm going to ask you questions, and we're going to answer. So, how do you think does the formation of the cinder cone volcano differ from that of a shield volcano? So, Brianna.
A cone volcano forms from particles and blobs of solidified lava ejected from a single vent that fails as cinders around it, creating steep slopes. In contrast, a shield volcano forms from fluid lava flows that spread widely, creating a broad and gently sloping structure.
Thank you for that. No, precisely. No, that is the gist of the cinder cone volcano. So now let's move to the next question. So why do composite volcanoes tend to have more eruption compared to field volcanoes? So can we have Vinci Marie to answer that question? Okay, so looks like Vinci Marie has technical issues. So can we have Brianna Tapdasan to answer?
For me, composite volcanoes have viscous lava that traps gases, building up pressure until it explodes, while shield volcanoes have fluid lava that allows gases to escape easily, making eruptions less violent. Po teacher.
No, precisely. Thank you for that, Miss Tapdasan. So now let's proceed to the next question. So, what similarities and differences can you find between Mount Mayon and Mount Mauna Loa based on their volcanic type? So, who can answer this question?
Mount Mayon is a composite volcano with steep sides and explosive eruptions, while Mauna Loa is a shield volcano that is broad and has fluid, gentle lava flows.
Wow, precisely. Thank you for that, Brianna. No, seems like Brianna really listened to the lesson because she can answer successfully the question. So thank you, Miss Brianna. So now let's move on to the next types of volcano based on activity to be reported by teacher LJ.
Alright, thank you, Teacher Eliza. Now that we've learned about the types of volcanoes based on structure, like the composite volcanoes, the cinder cones, and the shield volcanoes, let's now move forward and talk about another way to classify volcanoes. So, volcanoes can be grouped not just by how they look, but also how they behave. So, this is what we call types of volcano based on activity. So, it has three main types: active, inactive, and potentially active volcanoes. So next slide, please. So active volcanoes. So these are volcanoes that have erupted at least once in the past 10,000 years. So they often show signs of activity even when they're not erupting, like gas emission, steam, or small earthquakes.
Inactive volcanoes. So these are the sleeping giants. So they haven't erupted for the last 10,000 years and they don't show signs that they will erupt anytime soon. So their structures are usually heavily eroded. But remember, inactive doesn't mean dead forever. Next slide. Potentially active volcanoes. So these are volcanoes that haven't erupted in recorded history but still look young. So their shape is preserved and they haven't undergone much erosion, meaning they might still erupt in the future. Next slide, please. Okay, now let's pause and reflect with a few questions. So just raise your virtual hands if you want to answer, or you can write your answer in the chat box. So first question is, why might a potentially active volcano be considered a future threat even without past eruptions? Okay, Kaz?
A potentially active volcano could be considered a future threat even without past eruptions because the volcano still looks young and preserved, meaning lava could still reach the surface if possible.
Okay, very good. Because their young and damaged shape suggests that they could still be capable of erupting even if there are no historical records of eruptions. Next slide, please. Okay, second question. In what ways can the appearance of a volcano help determine if it is inactive? Anyone? Okay, Jean?
Inactive volcanoes often have rounded tops, collapsed craters, or are overgrown with vegetation due to weathering over time.
Yes, sakto. Inactive volcanoes often show heavy weathering erosion and the breakdown of their original shape indicates that they have not erupted for a long time. Next slide, please. Okay, what might happen if people misunderstand the difference between inactive and potentially active volcanoes? So, anyone from the class? Okay, yes, Jingil again.
I believe they might build homes or structures too close to a potentially active na volcano, putting lives and property at risk if an unexpected eruption occurs.
Yes, of course. They might not prepare properly, no, thinking the volcano is completely safe when in fact it still possesses a danger. So, excellent answer, everyone. Prioritizing safety by avoiding as exposure, keeping informed, and following authorities' instruction are crucial steps immediately after such eruption. So, by knowing the sign and eruption types, we can predict, prepare, and protect lives. So, to know more about evacuation plan, let have an activity which is create your family emergency plan. So students will design a family or community emergency plan in case of a volcanic eruption. So with each group focusing on a specific aspect of the plan. So these are the materials needed: markers, colored pencils, cartolina. So for the group 1, evacuation routes and safety rules. For the group 2, emergency go bag and communication plan. And for the group 3, preparedness for vulnerable groups and additional tips. So these are the procedure of your emergency plan. First, create a detailed plan for your assigned aspects. Second is consider realistic situation for volcanic eruption in your community. And the third one is after creating the plan, each group will have one representative to present their emergency plan to the class. Kindly screenshot the evaluation rubrics. Thank you.
Right, so to check your understanding about our topic, we will have an assessment. So our assessment consists of multiplication choices, identification, and essay part. So I will give you 20 minutes to answer your assessment. Alright, so I have seen that all of you got a perfect score. Congratulations, everyone. Let's give everyone a virtual applause. So for your assignment, that will be passed next week. So you will go to your same group from the previous activity, and then our assignment is entitled Volcano Disaster Awareness Campaign short video. So to encourage students to use their creativity and communication skills to design a volcanic disaster preparedness campaign. So through this project, students will research important information about volcanic eruptions, synthesize it into a short video presentation, and share safety tips and preparedness strategies to raise awareness in their community or school. So procedure, you need to create a 1 to 2 minute video that explains volcanic eruption, preparedness, and safety. So you need to include volcano facts, preparedness tips, and lastly, call to action. So the assigned representative will upload the video presentation in our Google Classroom. So here is the criteria of your assignment. So that's all for our class today. Thank you guys for listening and see you next week. Bye!